on, those who have not joined can get benefited. Oh, okay. Okay, so welcome to this session. This session is all about the overview of Android, and if I ask anybody what is an Android, the simple answer from a non-technical person would be from a non-technical person. Okay, what would be the answer? It would be it is one of the mobile operating system. Okay, so it is one of the mobile operating system. So if now from a non-technical background, I would would like to jump to a technical thing. If it is an OS, okay, if I ask what is an OS from a technical person, and that person will mention that every OS has a stack of layers. So as it was mentioned that Android is also an OS, so Android also has a stack of layers. There are multiple layers, okay? So let's take one by one each layer and let's see what these layers are all about. Let's take the bottom layer. Let's start from the base layer, which is the Linux kernel layer. Okay. Generally, if you open up a dictionary and see what's the meaning of a kernel is a seed, okay, which is there inside a hard shell. So on the same basis, if you say a kernel of an operating system, so it's like a core thing from which the entire activities of operating systems are controlled. Okay, so the name of a kernel is because the central point of controlling of an operating system lies there. Okay, it's so named. Look at this second paragraph. The kernel is so named because, like a seed inside a hard shell, it exists within the OS and controls all the major functions. It's like a control panel. All major functions of a hardware, whether it's a phone, laptop, server, or any other kind of a computer. Okay, and if we talk about a mobile phone, so hardware of a mobile phone is controlled by this kernel. So on one side of the kernel, you have the hardware devices like CPU, memory, and devices. Okay, and on other side you have softwares. Okay, and here generally broadly it's applications written. Okay, but if you look at this diagram, system apps at the top layer and kernel is the bottom layer, and what comes in between are the softwares. So softwares are also kind of applications. These are also kind of applications, but these are not the user applications but the other layers of applications. These are also kind of other layers of applications. So these are the system applications which a user can operate. User sits on the top of system apps. Okay, so if we say that what are on the two sides of kernel, on one side of a kernel it lies a hardware, on other side of a kernel you have multiple kinds of applications. And here application doesn't only mean the system app, it means Java API framework, it means native C++ libraries, Android runtime, it also means hardware abstraction layer. So every kind of applications sits there in this applications block. Okay. So Linux kernel, we are talking about Linux kernel here. Okay, so there is an operating system called Linux. We have borrowed a kernel from Linux. Okay, and we got the advantage of borrowing that, all the advantages of a Linux operating system, the security, okay, whatever features of a Linux, whatever features that kernel is providing to Linux operating system are, carried to the Android just because of the Linux thing associated. So Linux kernel is the main component of a Linux operating system, and it's the core interface between computers hardware that we just mentioned and its processes or applications. Okay, so here processes or applications. It communicates between two managing resources as efficiently as possible, just because it is very near to the hardware. Okay, so every command that you give to kernel, it's immediately being sent to the hardware device, and hardware device starts functioning. Okay, so generally if we say what a kernel does, the kernel does 4 jobs: M, P, D, and S. M from memory management, it does memory management. P for process management, it does this process management. D for device drivers, it contains device drivers. And S for security and system calls. Okay, and these are general tasks of a kernel of any operating system, not specifically to the Android, which is a mobile operating system. So kernel basically does these 4 possible jobs. And as mentioned that a kernel is a kind of a seed which controls all the possible major functions of a hardware. Okay, and these major functions of a hardware are categorized into the four categories: memory management. Okay, keep track of how much memory is used to store and where. Okay, all the activities that are related to memory. Okay, process management, operating system, many processes are there. Determine which processes can use CPU, when and for how long. Which processes can use input output burst, which processes can use which particular unit of a system. Okay, all this management of processes, okay, is managed by the kernel. Device drivers, as I said, that kernel is a seed which, on one side you have a hardware. So hardware, in order to operate on the hardware, you need drivers. So all the drivers, responsibility for all the drivers lies with the kernel. So it acts as a mediator and interpreter between the hardware and processes. Okay, and yes, system calls and security just is also responsibility of the kernel. Okay, receive requests for a service from processes, and it checks that request, whether that request is a valid request or not, whether authentication proper is available or not, or authorization can be granted or not. Okay, all those ifs and buts are taken care by the kernel. So four things: MPDS. Okay, remember these four activities of kernel: memory management, process management, device drivers, system calls, and security. So the kernel is a foundation. Okay, so see, even it's not only like the hardware devices can be interfaced to the kernel, but applications are also connected. See, not only the immediate applications, not only hardware abstraction applications, even this ART is also dealing with kernel. Even this native C++ library is also dealing with kernel through HEL. Okay, this Java API framework is also dealing with the kernel. Okay, in fact, what happens when user uses some, let's say, camera, okay, open up a camera application, that request gets translated into the form of Java API framework, then again it is translated into Android runtime, and then again it boils down to the kernel, and kernel sees whether it has a driver for a camera. Yes, it's a driver for a camera. It activates the camera. Okay, then so if we talk about Android runtime, it uses this Linux kernel. So it is, this kernel is a base foundation of the entire Android operating system. So this is what this slide is all about. Android runtime relies on Linux kernel. Okay, so security features comes with the Linux kernel, because and moreover, the developers, device manufacturers, okay, they they trust Linux kernel because Linux kernel is already established. Okay, because it was a part of Linux operating system. It allows device manufacturers to develop hardware drivers for a well-known kernel. They know what a Linux kernel is capable of. Okay, then let's talk about layer number 2. Okay, which is HAL. It's a hardware abstraction layer. Okay, it sits on top of the kernel. Okay, so what HAL provides? What do you mean by HAL? Hardware abstraction layer. What does it provide? So see, just look at this diagram carefully. This hardware abstraction layer provides standard interfaces. Just imagine that this HAL, this box is an HAL layer of an Android operating system, and these bars are interfaces. Okay, so these bars are the interfaces. Interfaces are the means to access the functionality. Okay, so for any layer or for any object, okay, interfaces are the only means to access the functionality which lies beneath. Okay, just imagine there is a Java API framework. Okay, and that Java API framework is also able to communicate only through interfaces. So these yellow bars are the interfaces for the Java API framework, and these orange bars are the interfaces for the HAL, which is hardware abstraction layer. Okay, so hardware abstraction layer, it provides standard interfaces, so these yellow bars, to expose device hardware capabilities. Let's say it they request, suppose Java API wants to connect to a camera. Suppose this represents a camera, and this represents to a Bluetooth, and this represents to some other hardware. Okay, so if Java API framework wants to communicate to the camera, let's say, okay, it will connect to the interface of HAL. Okay, and this HAL will provide a functionality through the kernel to the camera. Okay, so this black line is actually I have intentionally marked it as a black line because it acts like a black box. Okay, because what is underneath, it's implemented in the terms of libraries and many of the things that we will see in the further slides. Okay, so but on a nutshell, if you look at from the top angle, you'll see that this HAL provides what? It provides standards interfaces that expose device hardware capabilities, like click of a camera. Okay, you want that picture has to be clicked and saved into a SD card or internal memory, or you want to enable the Bluetooth because you want to send some file through the Bluetooth. Okay, so you have enabled this through Java API framework. Java API framework is talking to HAL. Okay, these interfaces are talking to the interfaces of HAL, and these interfaces are letting this Java API framework connect to the features of a hardware through the kernel, of course. Okay, because kernel is a base. Okay, now what HAL consists of? This slide mentioned what HAL provides. It provides standard set of interfaces. Okay, and what HAL consists of? HAL consists of so many LMs. That means library modules. LM1, LM2, LM3. Let's imagine there are N library modules. Okay, and what these library modules are doing? These library modules, see, these I mentioned you in this example that these are the interfaces of HAL. So inside LM also implements interfaces. Okay, each LM has an interface. They implement an interface to a hardware component module. For example, this library module is implementing a hardware component module for a camera. Another library module is implementing a hardware. Let's say here in this example, I mentioned you that this is a black line. Okay, because this black line on the top, you are not able to see what is inside it. But here, if you look clearly inside HAL, you will see that there are so many LMs. Okay, there are so many LMs which are there inside this HAL library modules. Okay, and those library modules are responsible for connecting to the components of the camera, components of the Bluetooth, of course, through the kernel. Okay, so this arbitrary library module number K. Okay, I just imagine there are N library modules. So if I take one library module out of this, okay, what does this do? It implements an interface for a specific type of a hardware component like camera, Bluetooth module. I hope you have understood what HAL consists of. HAL consists of, if you think of HAL, just remember this diagram. Okay, so it consists of lots of LMs, means it consists of lots of library modules, and each library module implements an interface for a specific type of hardware component, be it a camera, be it a Bluetooth, or be it anything. Okay, so it contains n number of library modules. Okay, so how ML functions? This is how HAL, sorry. This is how HAL functions. When a framework API, let's say this framework API that we saw here also, Java framework API, when this API requests for some service, and this API requests for some service, let's say from this interface, it wants to access camera. Okay, so this library module, which is implementing an interface for a camera, is loaded into a memory. So this is a memory. If you just say that this is a memory, it's loaded into a memory. Okay, let's say H module, library module number H, okay, is loaded into a memory so that camera accessibility can be provided to this framework API. Okay, this is how HAL functions. This is how hardware abstraction layer functions. Okay, now let's talk about the next thing, which is Android runtime. So we covered here in brief. We covered, let's say, if I talk about, we covered here Linux kernel in brief. We didn't go into detail. We will go into detail in the next lectures to come. Okay, and we also mentioned something about HAL. Now I'm concentrating on Android runtime. What is Android runtime? Let's talk about Android runtime. So this is how Android runtime looks like. Okay, it consists of ART and it consists of code libraries. So let's talk about ART. So for devices running Android version 5.0 API and API level 21 or higher, let's say this is a device. Just imagine this is a device, okay, mobile device, and this mobile device is running Android version 5.0 or higher. In that case, every app, just imagine that this is an app. Okay, this smiley face is an app. Okay, and this cloud is like a process. Okay, and this ART is Android runtime. So in a mobile phone which is running Android version 5.0 or higher, okay, every app has its own process, runs its own process, and with its own instance of ART. So every app is happy to say that it's my process and it's my IRT. One instance of ART, okay, my process my instance of ART, my process, my instance of ART, my process, my instance of ART. So every app runs in its own process and with its own instance of ART. Okay. So how ART is written? Okay. ART is written to run multiple virtual machines. Let's say there are T virtual machines on low memory devices. Let's say LMD stands for low memory devices. So it's written in a way that it is able to support multiple virtual machines on multiple low memory devices. By doing what? By executing this DEX file. Okay, DEX is Dalvik executable file. Okay, that gets converted from a build tool like Jack. Suppose Jack is an example of a build tool that takes Java source file as an input. It converts that Java source file, which is a class file, sorry, which is a Java file, okay, Java programming language file, into a DEX class file. And that is run by ART, and this kind of facility is provided. Okay, so if you look at this diagram, then you can make sense out of what is written over here. ART is written to run multiple virtual machines. So it's able to run multiple virtual machines. Let's say T virtual machines are there on low memory devices, on low memory device 1, 2, 3, and let's say T low memory devices. By executing DEX files, a bytecode format designed specifically for Android that's optimized for minimal memory footprint. Okay, and I've also mentioned some extra piece of information that this DEX file is an output. It can be an output of a build tool, which is Jack. Okay, and it takes input from a Java source file and it converts that Java source file into a DEX file. And that DEX file can be run using on ART so that this can be done. The support of virtual machines on low memory devices can be provided. So what are the major features of ART? The way we mentioned that the task of kernel is MPDS, and here we will say the task of the features of ART. ART means Android Runtime, or CGOD. Okay, C stands for it supports compilation, give you compilation support. So two kinds of compilation is possible: ahead of time compilation, just in time compilation. Ahead of time, that means before running you have to compile. It's not during execution you have to compile. JIT is during execution. This is before execution. Ahead of time compilation and just in time compilation. C stands for compilation. So one of the feature of ART is compilation support. G stands for garbage collection. So it provides you optimized garbage collection. O stands for optimized code. Okay, optimized machine code, compact machine code. Okay, the DEX files are more compact. If you talk about Android 9, which is API level 28 and higher, conversion of an app packages Dalvik executable format files to more compact machine code. Before that, the machine code was not compact, but after Android 9, machine code was more compact. D stands for debugging features. Okay, so better debugging support is provided. For example, dedicated sampling profiler, detailed diagnostic exceptions, and crash reporting. And moreover, the ability to set watch points to monitor specific fields. Okay, so these are the four major features of ART, Android Runtime. If you talk about the older version of an Android ART, okay, prior to Android version 5.0, that's API level 21, Dalvik was the Android runtime. Okay, so there is a communication kind of a thing. Let's say if your app runs well on ART, then it should work on Dalvik as well. But the reverse may not be true. That means if you have written your application specifically for Dalvik, okay, it might not run on ART. But if your application is running well on ART, then it should work on Dalvik. Okay. So target your application for ART, not for Dalvik only. So, there's another component of Android runtime is other than ART, it's a core libraries. Okay, so core runtime libraries provide most of the functionality of Java programming language. For example, Java 8 language features, okay, are available through this core libraries. Okay, so then let's talk about native C++ libraries. Let me just make a reference to this diagram. So we have covered this Android runtime in brief. Okay, now I am covering this native C++ libraries. Okay, so let's talk about this native C++ libraries. Okay, so what is the need of these native libraries? If you look into the configuration of ART, if you look into how ART is written and how this HAL are written, okay, or other components are written, they are written in actually native code, which is requiring CC++ library. Okay, so HAL and ART. Okay, these are there. So that's why you need to provide a support for native libraries, just CC++ library, because ART is written in native code requiring CC++ library. Even HL is also written in native code. Okay, and moreover, using these libraries, okay, see, this is native library I'm talking about. Okay, so Android provides a Java framework API. Okay, just example, HAL, you have, interfaces. So this Java API framework is also extending interfaces. Okay, so applications, this is, just imagine this is an application. Okay, to Android platform provide Java framework API. This is Java framework API to expose the functionality of some of these native libraries. Native library, I told you that ART is made using native libraries. Okay, HL is made using native libraries. So the features of native libraries are accessible through to the apps using framework API. Through the features of native library, you can also access HAL, you can also access ART through, you means you are here, okay, as an app. You are using app, that means you are using the features of native library through the Java API framework. You are making use of this Java API framework to access native library exclusively, to access the tools which are written in native library, for example, Android runtime and HAL, okay. For example, you can access OpenGL ES. Okay, suppose one of the library in native library is OpenGL ES. Let's say here, if we talk about OpenGL ES. See, this is one of the native library, OpenGL. You can access this, okay, through the Android frameworks Java OpenGL API. If you replace this with Java OpenGL API to add support for drawing, why do you do this? So that because it is allowing you to draw. Okay, drawing and manipulating 2D and 3D graphics in your app. Okay, number two, example number two, Android NDK. Okay, Android NDK is a API, okay, that provides you to write code in CC++. Okay, if you are developing an app that requires CC++, I hope that they are might be using NDK. Okay, requires CC++ code. You can use Android NDK to access some of these native platform libraries directly from your native code. Okay, now let's talk about Java API framework. Okay, now we are here, here, let's say here, we are here now, Java API framework. Okay, let's see what is inside it. Okay, so how does Java API framework, what does, okay, not how, but what does Java API framework provides? The first thing that it provides is that it provides entire feature set of Android OS. If you think that, okay, Android provides certain features, it's because of this Java API framework. Okay, so this API framework we are talking about, which is there at central point in this case. Okay, so all the features are provided through Java API framework. And moreover, Java API framework is also a building block. It's also providing you a building block for apps. So I told you in this example that just imagine that this is an app. Okay, and here also in some earlier slide also, so here every app says that I am running in my own process, I'm running with my own instance of ART. So wherever you see smiley in this whole presentation, you just take it as an application. Okay, and here also you take that Java API framework provides you a platform, okay, provides you a base for designing applications. You can design applications by simplify the reuse of M, C, and S. By simplifying the use of MCS, there are three components. Okay, reuse modular system components, reuse core components, and reuse the services. Okay, let's take examples of what are these M's, what are these C's, and what are these S's. So components of MCS simplified by Java API framework. So this Java API framework is simplifying the use of these things so that application development can be facilitated. Okay, so then you can design applications happily. Okay, so MCS are the collections of the view system, rich and extensible view system you can use to build a new apps UI, including lists, grids, text boxes, buttons, and even an embedded web browser. We saw many of these things in the lectures that we went on, that we saw. A resource manager providing access to known code resources, for example, string.xml file. Okay, there are some resources which are responsible for, if language settings, for example. The resource manager provides access to non-code resources such as localized strings, graphics, and layout files. Notification manager that enables all apps to display custom alerts in the status bar. If some message comes, it automatically pops up a window that message has arrived. Okay, not the window as a pop-up window at the center of a screen, but at the top. Okay, an activity manager that manages the life cycle of apps and provides a common navigation backstack. Moreover, a content provider is also part of IMCS. Okay, content providers that enable access to apps to access data from other apps, such as the contacts app, or share their own data. Now we are at the top layer, which is system apps. Okay. Now you can see some of the applications which are already there: dialer, email, calendar, camera. Okay, there are some applications which are already installed, and there are some applications that you can install by downloading from Play Store, etc. Okay, but see, these are some of the core apps that I just talked about. Core apps means they come built in with an operating system. Okay, when you install an operating system. Email, SMS messaging, calendars, internet browsing, contacts, and more. Even though these are the core apps, but they do not have any special status. They do not enjoy any special status because if you have a better version of these applications, you can replace these core applications with your applications. So apps included with the platform have no special status among the apps. Okay, the user chooses to install. So a third-party app can become the user's default web browser. It can also become third-party app, can also become a SMS messenger. It can also be a default keyboard. Okay, but there are some exceptions. Okay, though you can change anything, but you cannot change the settings app. Okay, some exceptions apply. You cannot change the settings app. Okay, so system apps has dual responsibility. They do two things. One, they provide apps so that users can use. Another thing, they also provide the capability to the developers. For example, if you are an Android developer, okay, and you want to use certain feature, suppose your application wants to send a SMS message. So rather than designing your own SMS messenger, you can use the system app. Okay, if your app would like to deliver an SMS message, you don't need to build that functionality yourself. You can instead invoke whichever SMS app is already installed to deliver a message to the recipient you specify. Okay. So this is it for today's session. Next lecture will be on history of Android. Okay. And in case you have any questions, and in case you think that some modifications are required in this lecture, then you can pose a question in the chat window, or you can also ask verbally. Okay. And let me just stop the share, and I'll provide you the link of the attendance. Okay. You are free to ask questions. Any kind of question.
सर ये रिकॉर्डिंग एंड पीपीटी आप शेयर कर दीजिए सर मोडल पे.
Yes, that is implicit. I'll do that. No issue in that.
ओके सर. हेलो सर।
Yes.
सर सलोनी को एंट्री दे दीजिए सर, सलोनी का डिस्कनेक्ट हो गया था।
Okay, I have already allowed her.
ओके।
Okay, now you can mark your attendance. I posted an attendance link.